Hello, class. This is Mr. Hart, and in this podcast, I want to go over balancing chemical equations. Okay, this is a part of chemistry and of eighth grade science that a lot of students struggle with, not because it's necessarily a difficult concept, but just it's a unique concept and one that is taught a lot of different ways, and there's a lot of ways of viewing it. So sometimes students can get confused. So I wanted to make this podcast so that we could specifically go over the different methods and kind of help you find a method that works for you to balance chemical equations. Okay, so there's kind of three main methods that I'm aware of for balancing chemical equations. I'm sure there's even more than the ones listed here, but I kind of like to think of these three. So the first kind is just kind of a trial and error. You plug in numbers to, until it works out, kind of using logic and reasoning to get a correct solution. There's also drawing it out, visualizing how many atoms you have on each side, okay, to balance an equation. And there's also the direct multiply method, which is kind of more of a mathematical method. So some students really like this because it's just kind of a set of steps. Okay, so we're going to go over all three of these methods, okay? So again, you don't have to understand all three, just use the one that works for you. So as we go through these, see which one you like the most and kind of stick to that method, okay? All right, so the easiest way to get into balancing equations is just to start practicing, okay? So here's a chemical equation, okay? We have carbon and sulfur coming together to make carbon disulfide, okay? And again, the goal of balancing an equation is so that you have the same amount of atoms on each side of the equation, okay? Because if you look at it right now, I have one atom of carbon, one atom of sulfur, but I have two atoms of sulfur on this side. So our goal is to make the same amount of atoms on each side, okay? So let's just start with the trial and error method, okay? So on the trial and error method, we just kind of plug in numbers until it makes sense, right? So if you look here, I have one sulfur here, I got two sulfurs there. So to start out, let's just plug in 2 right here. Okay, I want to get 2 sulfurs on this side, so it matches the 2 sulfurs on that side. Okay, then I have one carbon here, and I have one carbon here. Okay, so those actually match. So let's just stick with one carbon. Okay, and then if we look, we have one carbon and 2 sulfurs, and we have one carbon and 2 sulfurs. Okay, so we'll stick with one here, and there you go. Our equation is balanced. Okay, just took a little bit of reasoning to make sense that we just need 2 more sulfurs, or 2 sulfurs on this side to match the 2 sulfurs on that side. Okay, now this is a really easy example. Okay, but we could just use trial and error. Okay, a little bit of logic. So let's go through a little bit more of a complex example. Okay, so again, we're going to do kind of trial and error. Okay, but this time we got nitrogen 2 over here and hydrogen 2 over here, and it's going to combine together to give us NH3. Okay, and so we want to again balance the equation. So right now we have 2 nitrogens on this side, but only 1 on this side, and we have 2 hydrogens on this side, but 3 on this side. Okay, so if we kind of think trial and error again, think logically. Okay, you'll notice we have odd numbers on this side and even numbers on this side. Okay, so one of the tricks that people use a lot is if we have an odd number on its side and evens on the other side, let's double this odd number, okay, so that we can have evens on both sides. So now we have 2 nitrogens and 6 hydrogens. That gives us even numbers, okay, on both sides of the equation, okay? Now let's think a little bit. Let's go through it. Let's think through it. So we have 2 nitrogens on this side and we have 2 nitrogens on this side. Okay, so let's just stick with that. Okay, so right now we're good. We'll stick with the 2 nitrogens. And now we have 2 hydrogens on this side and 6 hydrogens now. 2 times 3. 6 hydrogens on this side. Okay, so if I want H2 to turn into 6, I'm going to have to times that by 3. Okay, 3 times 2 gives me 6. 2 times 3 gives me 6. Okay, so now let's check it. We got 2 nitrogens on this side, 2 nitrogens on this side. We got 6, 3 times 2 hydrogens on this side, and 6, 3 times 2 hydrogens on this side. Okay, so there we go. Our equation is balanced, and we're good. Okay? Okay, so again, that's more the trial and error type method. Okay, that works for some people. Okay, some people can just do it in their head really quick, and they just get the hang of it, and they can just do trial and error and it works out. If you're one of those people and you get it right away, awesome. Stick to that method and do it. Okay? Let's go through the second method, though. Some people, it helps to kind of draw out what is happening, to get kind of a visualization. Okay, so let's try this example using the drawing it out method. Okay, so we have nitrogen and oxygen combined together, and it's going to go into N2 and O2. Okay, so you'll notice here on the bottom I kind of drawn out the molecule. So if red is the nitrogens and blue is the oxygens, so we have an NO over here, and a dinitrogen and a dioxygen over here. Okay, two N's and two O's combined. Okay, so let's count how many reds and how many blues we have on each side. So we have one red on this side, we have two reds on this side, and we have one blue on this side and two blues on this side. Okay, so we can obviously see we're not balanced here. Okay, so let's try and figure it out. So right away we have less on this side, so let's group these guys. Okay, and let's make another one. Okay, so now we have two of these guys. Okay, so now let's count the dots. So we have two reds on this side, two reds on this side. Okay, that's balanced. We got two blues on this side and two blues on that side. Okay, that's balanced. Okay, so now we have our balanced equation. There's the same amount of reds and blues, or the same amount of nitrogens and oxygens on both sides of this equation. Okay, so now we just got to figure out, let's draw out, or let's balance this equation based on what we drew out. Okay, so you'll notice we have two of these NO molecules. Okay, so we're going to put two in front of this because we have two of them drawn out here. Okay, now we have one of the N2 molecules. Okay, we have one there, and we have one of the O2 molecules on this side. Okay, so there we go. Our equation's 2, 1, and 1. Now it's balanced. Okay, so that's how we do this, right? We just draw it out and we see what it takes, what we have to add to both sides so this is balanced. Okay, let's try another example. Okay, this one's a really common one. This is H2, okay, H2 hydrogen, okay, and oxygen, O2, combining to get H2O. Okay, so again, I've just drawn out one of each of the molecules to start with, and let's count how many we have on each side. So if hydrogen's red and oxygen's blue, we got two hydrogens on this side, two oxygens on this side, and on this side we got two hydrogens but only one oxygen. Oops, I realized I flipped these. Sorry, the blue is supposed to be hydrogen and the red's supposed to be oxygen. Okay, sorry about that. Okay, so now blue is hydrogen, red is oxygen. Okay, so you'll see we have two hydrogens on this side and only one oxygen. Okay, so we have one oxygen, but we have two over here. So we need to increase the number of oxygen we have on this side. So let's copy one of these guys, okay, and put two of them on this side. Okay, so now we have two red ones, two oxygens, right, and four blue ones, four hydrogens. Okay, so now we got two blue on this side, but four on this side. So now we need to increase the number of hydrogens we have on this side. So let's make another set of these guys. Okay, and now let's count it out. So we have 1, 2, 3, 4 blues or hydrogens on this side, and we got 1, 2, 3, 4 blues or hydrogens on this side. So that's balanced. Now we got 1, 2 reds or oxygens on this side, and we have 1, 2 reds or oxygens on this side. So it's balanced, right? We have the same number of dots on each side. So we're good. So now we just draw it out, okay, or we write out what we drew, right? So we have two of these guys right here. We have one of these guys right here, and we have two of these guys right here. Okay? So, again, this is one method you can do it. If you really like to visualize it, this is a great way to help you balance out the equations, to draw them out, okay, see what you need more of on each side until you can figure out the number of molecules you need. Okay? All right, so that's another way you can balance these equations. Okay? So let's go to the last method. So the last method, if you can't do trial and error and you aren't quite figuring out drawing it out, you can try the direct multiply method. This is more of a direct way of doing it. It's more a mathematical way. Okay, so some people really like this one, some people really hate it, but let's just go through it and you can see how it works. Okay, so let's look at this one. So we have PCl3 on this side, and it makes P4 and Cl. Okay, so when you're doing the direct multiply method, you look at the molecule you're making. Okay, the biggest molecule you're making. Okay, or in this case, the combined molecule, and you find out what you need to multiply each side by to make that molecule. Okay, so let me kind of just draw it out, and write it out. I think it'll start to make sense. So I have P4 over here, but I only have one P over here. So what do I need to multiply 4 by to give me this hidden 1 that's right here, right? So what do I need to multiply 4 by to give me 1? Well, I need to multiply 4 by 0.25. Okay, 1/4, right? 0.25. That's what I multiply 4 by to get 1. Okay. Now, what do I need to multiply Cl by, or 1 by, to get 3? Okay. Well, in this case, I need to multiply it by 3, right? 1 times 3 gives me 1 times 3 gives me 3, right? So now you see, to start out, I'm just seeing what do I need to multiply this number by to get the number over here. Okay, and then you just write 1 for the compound molecule. Okay, but this isn't, well, this is balanced, but it doesn't make practical sense, right? Because you can't have 1/4 of a molecule. Okay, so what we need to do is we need to multiply both sides by a number so that this is a balanced equation and a practical equation, right? A real equation. Okay, so I can't have 0.25, so what number would I need to multiply 0.25 by? Well, it's going to be 4. So we're going to take each number and multiply it by 4. Okay, so 1 times 4 is going to be 4. Okay, 0.25 times 4 is going to be 1. And 3 times 4 is going to be 12. Okay, so there you go. That's our balanced equation. 4, 1, 12. Okay, so I put this equation specifically first because it kind of shows the power of direct multiply. When we're working with really big numbers, okay, like 4 and 12, sometimes drawing it out doesn't make as much sense, and sometimes it's harder to do trial and error. Okay, so this method works really well for some of the bigger numbers and bigger compounds. Okay, but that's all you're doing is you directly multiply what you need to get the other molecule, and then you just multiply it by another factor so that it's all real numbers, all whole numbers, right? Numbers you could use in a real equation. Okay. All right, let's do one more example to see if this see if we got this. Okay. All right, so here's our other example. So we have carbon combining with O3 to make CO2. Okay, so we're going to use the direct multiply method again. Okay, and so now we need to see what do we need to multiply C by to get C. Well, in that case, it's just going to be 1, right? That's pretty simple. Okay, and now we want to see what do we need to multiply O3 by to get O2. Well, to get 3 to turn into 2, you need to times it by 2/3, right? If you times it by 2/3, you're going to get 2. Or in other words, 0.666 going on forever, right? So 0.66, okay? However you want to think of it, right? But that's what you would multiply 3 by to get 2, okay? And then we write 1 over here. Okay, so there's our direct multiply, 1, 0.66, and 1. But again, we can't use those fractions because it doesn't make sense to have a 0.66 of a molecule, right? So now we need to times them all by something that makes sense, okay, or that will turn it into something that is a real equation that makes sense, has whole numbers, okay? So what do I need to times 2/3 by to get a whole number? Well, it's going to be 3, right? I want to get rid of this 3, so I'm going to times it by 3. Okay, so 1 times 3 is going to give me 3, okay? 2/3 times by 3 is going to give me 2. and then 1 times 3 is going to give me 3. Okay, so there we go. There's our balanced equation using direct multiply. Okay? All right, so again, you're just directly multiplying what you need to get the other molecule first. Then you times by another factor to make it all whole numbers. Okay? Okay, and again, if you may like that method, you may not. Okay, but that's how you do it. So if you like it, stay with it. If not, you can use one of the other methods. That's fine. Okay? All right, so that is how you balance an equation. So those are the 3 methods. Okay, trial and error, drawing it out, and directly multiply. Again, stick with the one that makes sense to you, or maybe you like all 3 and you use one for different types of chemical equations. That's fine too. I just want you to have a way that you can balance an equation, okay? And so make sure you practice this, make sure you understand how to do this, and do it in the way that makes sense to you. Okay, so let me know if you have any questions, and thank you for watching.